Back again, guys. Just here to talk about the diesel heater. I got a fantastic discovery and invention. Guess you'll just have to watch to find out what it is. But anyway, I'm really excited about it. But here's my porch. I have a diesel heater here. Step outside, we got snow. You look up there, I don't know if it'll focus, but we got a bunch of snow. So I'm out in the garage. Super glad you could join me with this. So yeah, this is the invention and the discovery. So it might not seem so awesome to you, but to me, I am a huge fan of these diesel heaters. I got a bunch of them. I do tons of experiments with them. This might be my best one so far. It's pretty exciting to me. To me, it's a discovery. I haven't seen anything like this. I've watched, so many diesel heater videos. I've watched hundreds of hours of them, so I kind of know what I'm talking about here. Like for example, this is the self-contained unit. I think I talked about it before, but here's what happens. This heater, I'm just firing it up now. It's gonna start up. This exhaust pipe right here gets like 300 some plus degrees, and it's blowing out heat into the environment. So my thought is, I put this really cool cast iron old thing up and heat it up. Well, that was my last video, and it worked. But then I was leaking here, and you can see my homemade attempt here. I've already ordered the parts for this steam radiator, so I can direct connect this with plumbing parts a little bit better. But yeah, over here too. But for now, this is work. It's a test bed. You should never have your exhaust higher than your heater. With these diesel heaters, they make moisture. It's not a good idea. But this goes down and then under the heater and up, so nothing's really going to happen. Plus, that stays hot enough to boil it and steam it off. And it goes into the bottom here. And like what I noticed, what my huge discovery was, is this produces a ridiculous amount of heat. So much heat, in fact. I don't have my thermometer. I wish I had it. I have two of them, actually. Just misplaced them. But I could put it right here. And this is hot to the touch within minutes. And it gradually spreads through the whole radiator. I was running it earlier, but it was leaking out this point. So that's what we're testing right now, is this jury-rigged. It's basically a tinfoil gasket. And it goes, there's a 1-inch output port here, a 3/4 inch. I haven't measured it. So I ordered both the little steam ends or whatever. And so I'm going to have both those coming. I can always plumb those up and make it work, especially with different tubing. But anyway, here comes the invention for it. So basically, it kind of evolved, but it started with this top part gets hot enough to cook on. And so this would provide heat, and it provides a hot water heater. So you could just put a water tank on top of here, and over time, if you ran this, it would get hot, heat the water, you could take a shower. It would do it quite quickly right here up on this spot. But so that's not an invention. This is a 200-pound cast iron radiator from $1 million house. Probably won't find one of this design. They're not that common, I wouldn't think. But they got the old steam ones that work just fine. You could put that in your workshop, your home, pretty much anywhere. This thing's a little loud on camera. Sorry about that. It sounds like a jet engine, but it's clicking away. But anyway, so not only that, but you can cook on it. It's hot enough to cook on. You can't even touch that. So you put a pan or a boiling water. You take a hot shower from it. You can cook on it. And you wouldn't have to be this giant radiator. You could make another thermal mass out of like a radiator set in some concrete. Just take a regular old radiator, adapt it to go to this muffler. You pour the concrete on the radiator, and you got yourself a thermal heat sink. Now, it wouldn't be as efficient as an iron. Alright, back again. My video got cut off. I'm super excited, so I went in at like 1 a.m. It's been about 40 minutes, and I'll show you. I don't have my thermometer, my infrared laser thing, but I'll tell you, you can't touch beyond here, I mean, this is hot to the touch all the way around this area. But that 8 inches around here is so hot you could cook on it. And then this is probably 20 pounds, maybe 30 of cast iron that's untouchable. And then everything above, like this, is all hot. It's hot. I mean, this thing, it's outside, it's snowing. The temperature's only gone up about 8 degrees in 40 minutes, but this is a big garage. You look. We got my wood stove over there. That takes 2 hours to heat it up in here. This thing is kicking heat off. It is warming the air. This is a ton of wasted energy. I never expected it to get so hot so quick. But anyway, so I've been thinking about it, and a device I could make for any van lifer or RVer, or basically anybody. It's just a device that comes off the bottom here, and it's for the exhaust. Obviously, you'd have to make some kind of heat shield for the exhaust. And it's just a box, a cast iron box with some baffles in it. You take some of that heat directly off the heater, make a cooking surface slash, not necessarily, you could even put a valve in the exhaust line so you could shut off the main exhaust and it would pump through and around through this thing. But anyway, it would get hot. You could put a water tank underneath it and heat up a water tank with it. So if you put it out of the way, you could just have a water tank heater, super simple way, rather than a bunch of pumps and all that other stuff. Just a water tank with a vent for safety. Obviously, it's not going to boil the whole big container of water unless you left it on for a really long time. But I mean, maybe not, because this thing is hot. This thing's, it's well over 150 pounds. I don't know, I've never weighed it, but I struggle to lift it up here on this thing here. Got my carbon monoxide detector over there, and the boat motor hasn't gone off, so that's good. Kind of cool. I put my hand out there. If you look, you can see a little bit of what you think is smoke, but it's not. It's moisture. So this thing's just basically kicking steam outside, because by the time it goes through here and gets to here, this spot is only about probably 90 or 100 degrees, maybe 105. But this pipe is maybe 105. And this pipe's like 80. So it's sucking all that heat out of there. I mean, you can't even hardly touch down here. I bet that's 150 all through here. And then in there's over 200. It burns you instantly. And then this is probably, that's about 180. But that's because the heat's rising, going straight up that riser. But anyway, so yeah, you could make like a box that you could heat or cook food. I mean, you could cook food with that heat for sure. I just never seen anybody capture this exhaust heat and measure it. I'm sure I could weigh this and do all the caloric index and figure out how many BTUs is coming out. And I'm telling you, it's a lot. I mean, you could use this heater to heat up a hot tub, with a specially designed radiator. You could literally heat a hot tub, a swimming pool, maybe not. Be interesting to check how many BTUs, but it's a lot. I mean, I have an oil-filled radiator, and if I plug that sucker in, it doesn't get this hot. It does not get that hot, and not that quick either. So this is more than 1,500 watts. I guarantee that, 1.5 kilowatts. And when you shut it off, this thing stays hot for hours. When I came out here, probably 20 degrees, 25 degrees. And this heater was at 3 degrees Celsius when I first looked. So whatever that is. That's how cold this metal was. And my earlier experiments where this was leaking, I've done several. That's why I got all this tools and mess. Because I'm trying to create a sealed gasket, which I have now. I don't worry too much about carbon monoxide, but I do have a detector, and there's a huge fresh air vent at the top of my garage there. But I'm just so excited. Like, who knew there was that much heat being released? And there's a lot of inventions and ideas I've had because of this. I mean, in the third world, for example, like India or China, or not third world, but, you know, anywhere where heat's at a premium, you know, and cost, this is really, I mean, you can buy a radiator, cast iron radiator, you know, the old style. I've moved them for years, and they come anywhere from 100 pounds all the way up to 1,000. I've moved them. And this will eventually heat up, the entire thing, because the heat has worked its way over, and it's steadily increasing. We got, I mean, down here, back here, you can barely touch it. It will burn you. This, especially this rail straight off, that's hot. That burns you. That's pretty sweet. And that's over 100 pounds, probably closer to 200 pounds of cast iron. But even if it was 1,000, it would eventually heat up. This has only been running for 40 minutes. And that's just a huge heat sink, heat storage. I mean, the possibilities, I see a lot. Anyway, thanks for watching. I would put this in my top 5 kind of things to mess around with, because I got a bunch of these diesel heaters. I'm making a greenhouse that I can grow plants all winter long. And I've already been working on that. My idea was to make a thermal mass, but use the ground and run the pipe underground. And now I have the perfect thing. I can just bury a radiator in the ground, deep down, duct that exhaust through that radiator to absorb all that heat and disperse it over time. But you could make a heat sink out of pipes, you know, pipes or an old radiator and coat it with concrete, and to have a thermal mass or a heat sink, take advantage of it. It wouldn't be as efficient as this. It'd be best to use iron, but, you know, that's at a premium. There's a lot of ways you could capitalize on all these BTUs of free heat. I know I've seen devices that go on the output here, and it creates hot water, like there's a water pump, and you pump water around, and you get, you get water for a shower. This can do the same thing. I put a pot right here, and it'll heat the water up enough for a shower real quick. Or right here especially. So you imagine my box that I came up with. Just a thick steel box, plate, and a couple baffles. And there you go. It's a heating surface. And then obviously the muffler continues on. You know, and it's just a longer muffler than what comes. It says you can make a muffler up to 1 meter. But I've done a lot of experiments with a lot of mufflers over 6 feet long and had no issues. So, I mean, in longevity, that is. It's what people always talk about online. These things last a long time. All you have to do is, I haven't yet to do maintenance on one, and I've ran over 1,000 hours on all my heaters. Some of them over 2,000. And the only thing I do is I put polar power or fuel injection cleaner in with the fuel at recommended ratio, you know what it says on the bottle, and yeah, but that's it. That's the only mod. And I got that, obviously I talked about it in my last video. That's AC to DC converter. You get them, there's that model right there, there's the model number, HJS48040. That can control 2 of these at once. You can run them. I mean, that's all the power. It's a dial-in control, 14.2 volts. And there's a huge voltage drop on these. You can see 13.6, 14.2. You know, I mean, that's 0.6, but there's no wire. I mean, it's like a foot. On my other ones that are meant for remote mount, I've had huge voltage drops. So, anyway, that's just an issue they are. You just run that higher. And you can run multiples of these off one circuit there, and it can power them no problem, flawlessly, definitely. So that's how you hook one up indoors. You get one of those, simple as that. You wire it like that. Little flip up thing under there. You hook your power wires there, that plugs in. Bam! You're good to go. Anyway, if you like this, keep watching, because I'm going to have a ton more videos about this because I see potential in the idea of harvesting these BTUs and these awesome little heaters that freaking kick out like 28,000 BTUs. And they're already super efficient, not counting what you can get from them, from the exhaust heaters. There's just, obviously this is a super rough, just came up with it. I'm getting the fittings. I looked up all the fittings and stuff that I need to do this, so it's perfectly sealed and much safer than tin foil with crappy China hose clamps and tin foil stuffed in there. But it's not leaky. There's no smell in here. It's great. Just got a lot of hot air, you know. Love these controllers, by the way. This is the one that I prefer. I've tried them all. Done the dial one. There's a couple different digital ones, but this one, I just know how to use it. That's why I like it. But that heater core has a temperature sensor, or that heat exchanger, 175 at the output. But yeah, it's way hotter. That is hotter than 175 C. That's quite a volume of air. And like I said, this is harvesting most of the heat. I mean, this is warm, but I can sit there, hold it. I can hold that, hold that. But yeah, you get right here, it starts to get hot. That'll burn you right there. That's where it gets too hot. And that's after probably 45 minutes now, maybe 50. Anyway, thanks for watching. Hope to see you back here again.